In previous videos, we've spoke about atoms and atomic structure in terms of the three subatomic particles. So that was the tiny, tiny little particles that exist within the atom. And they were the protons, the neutrons, and the electrons. So we spoke about the protons in that they tell you what the element is. So if you know the number of protons that an atom has, you know what element that atom belongs to. And we can see that information from the atomic number, and that's given in the periodic table. And that's how the periodic table is arranged, by atomic number. Then there was the neutrons, which along with the protons gave the atoms their mass. And we learned before that the number of neutrons could actually change, meaning we could have different atoms from the same element but with different masses, and they were called isotopes. In this video we're going to focus more on the third subatomic particle, the only one left, which is the electrons. So the electrons are, again, tiny subatomic particles, but this time, instead of existing in the nucleus like the neutrons and the protons do, these particles occupy the space around the nucleus. We often say that they orbit the nucleus, so they kind of whiz around the outside very quickly, around the outside of the nucleus. And again, there is a kind of simplified diagram of what an atom might look like, or we might represent it as looking like that. So we've got the tiny nucleus in the middle with my little protons and neutrons, and then the electrons are going round the outside. Now the way I've drawn that there is not very good, it's not very useful, because it looks as if they're kind of just going round randomly, and there's maybe a random number and they're going in random directions at random spaces and distances away from the nucleus. That's not really true. So it's not random. Electrons will occupy certain what are called energy levels, and usually you'll hear these be called orbitals or shells. So in these videos I'm going to use the word orbitals, which I prefer because I like to think of the electrons as orbiting the nucleus. So we're going to talk about orbitals. So we need to know at National 5 level about the first three orbitals. So that's the first three kind of levels that the electrons are allowed to exist in. So the first orbital can hold 2 electrons, and only 2. The second can hold 8, and the third can hold 8 again. So what do we really mean? Well, as we go down the periodic table, we're going to see that you have an increasing number of electrons. You have more and more electrons as you go down the periodic table. And what they do is they fill up from the smallest orbitals, the ones that are closest to the nucleus, and they sort of build up going out the way. So why do they start from the middle and not the outside? Well, this is because that the negatively charged electrons are attracted to the positive nucleus. Because remember, within here, there's only the positive protons, and the neutrons are neutral. They have no charge. So the nucleus overall is positive, meaning that the negative electrons are attracted to that positivity. So they're going to start filling from the closest orbital, the closest shell to the nucleus. And then once that's full, once it's reached 2 electrons, you move on to the next orbital, and that will fill up until it gets to 8. So that's 10 electrons in total. And then if you have an atom that has 11 electrons, meaning no more can fit in the first or second orbital, you move on to the third orbital. And of course there are more. There are larger orbitals that can fit even more electrons. But at this level, we're just going to focus on the first 3 for just now. So, examples of what that might look like. So you could have an atom of, for example, hydrogen. So there's my tiny hydrogen nucleus. It's just got 1 proton in it. And in terms of electrons, remember these are atoms, so they're going to have the same number of electrons as they do protons. It's just a case of what that's going to look like. So to show you the shells, I will draw a ring or circle that looks like that. And then to represent my negatively charged electron, I'm going to draw a little X on the ring like that. So that's an atom of hydrogen. It has 1 proton and 1 electron. So in an atom of hydrogen, I only need 1 orbital. I only need 1 shell, no more, because I've only got 1 electron. If I move along the periodic table, I'll just show you my periodic table here. I've started at hydrogen, and now I'm going to move right along to helium, which has an atomic number of 2. So that means 2 protons, 2 electrons. So again, here is my nucleus. It has 2 protons. This time it's got 2 neutrons as well. I'm going to ignore them for the time being. They don't really matter just now. Again, start off with my first orbital. And I'm going to draw 1, 2 electrons. And that's me done. So again, I don't need another shell. And you'll notice that I've drawn the electrons on opposite sides from one another. And you'll notice a couple of other things as I go along, just kind of standard forms of how to draw the electrons onto the orbitals. And these are just accepted ways to represent where the electrons kind of exist within those orbitals. So moving on to my next example, which is lithium. Again, thinking about the periodic table, I'm going to have to go from helium down to lithium. So now I've got 3 electrons. So going back to my rules for how many electrons can occupy the orbitals, I'm going to need a second one this time. So I'm going to draw in the first one, and we'll populate that first. 1, 2 electrons. But now I've run out. I cannot fit a third electron into that first orbital. It's not allowed. So I have to draw in another one. And this time I'm going to draw them sort of in a line like that. Now, just to show you how I would like you to draw electrons once there are more than 2 in a shell, so for example the second or third orbital, I'm going to skip down to an atom of sodium, which is actually below lithium. So we've actually gained 8 electrons going from lithium to sodium. So we're going to need another shell. We're going to need to use that third shell this time. And that will allow me to show you how I'd like you to draw the electrons. So we're going to have 1, 2, 3 orbitals. And I'm going to start populating them. First orbital can house 2 electrons. The second can hold 8. Notice I've drawn them in pairs. And then the third, for that extra 11th electron, again, just like lithium, I'm going to add it to the top like that. Now you'll notice I've drawn that second orbital with electrons in pairs. There are a few reasons for this. Most of the explanations are higher level than National 5, but for just now, what I would remember is it's neat to stack them in pairs. Okay? So you have pairs of electrons. And that will become very important at higher levels to understand electrons in terms of pairs. But for just now, just remember, if you have an orbital that can hold 8 electrons, draw them in pairs. Okay. The final thing I want to mention in this video is, as we get more and more electrons in our atoms, as they become bigger, as we go down the periodic table, this will become a little bit annoying to keep drawing all the time, drawing out full diagrams for our atoms. So the last thing I want to mention is electron arrangement. And this is just a neater way that we can describe how many electrons are orbiting around an atom's nucleus and where they are, what shells they're in, what orbitals they're in. So all I'm going to do underneath each of these diagrams is write down what's called the electron arrangement for each one. And it's dead easy. All we do is write down a number to show how many electrons are in the first orbital, and then a comma, and then a number to represent how many electrons are in the second orbital, and then a comma, and so on. So for this first one, it's only got 1 electron, So its electron arrangement would just be 1. So it's obvious that the only electron we have would obviously be in the first orbital. Again, because the negative electron is attracted to the positive proton in the nucleus, so it's going to be nice and close. Second one, helium, is going to have an electron arrangement of 2 because both electrons are in the same shell, the same orbital. Moving on to lithium though, we have 2 electrons in the first orbital, and even though we have 3 electrons in total, the third one is not in the same shell. So just writing 3 for electron arrangement wouldn't really tell us where that electron is, and that's very important because this electron is now what we call an outer electron. In terms of reactions, in terms of actual chemistry, it's this electron that's going to be very important because it's on the outside. That's the one that's going to come into contact with other atoms and other particles first, which is going to be very important, which is why this electron arrangement is useful. And then our last one, well, going from the middle, building out the way, just like the electrons fill up, we would have 2 electrons in the first shell, comma, 8 in the second shell, and then 1 on the outer shell. So these arrangements of numbers and commas to show you how many electrons are on the orbitals is called the electron arrangement. So even though lithium, for example, had 3 electrons, its arrangement is 2, 1, because it has 2 electrons in the inner orbital and 1 in the outer orbital. And what's good is that we don't need to memorize or figure these out using diagrams because page 6 of the data book contains the electron arrangements for all the main group elements, which is really handy. So, to recap, electrons are the tiny subatomic particles that occupy the space around the nucleus. They're not inside the nucleus like the protons and the neutrons. They are negative, negatively charged, so they're attracted to the nucleus, so they orbit around it, and the electrons fill up different energy levels called orbitals or shells. And each orbital can hold a different number of electrons. First holding 2, and then 8, and then 8 again for the third orbital of electrons.